in the spirit of reduce, reuse, recycle, save a couple bucks so you can buy more RC stuff and keep filling your shelves. I thought I'd share one way you can reuse some old computing equipment to charge hobby batteries. So what I've done here, it kind of looks a little janky with all the wires everywhere, but what this is a power supply unit from an old Dell PC tower. And what I'm doing is it's taking the wall AC from the house, from the home, and it's converting it to a DC 12 volt out. And that's the input into this balance charger that I have here. So this is basically the similar setup to what you would have if you were to use your hobby charger off your 12 volt battery in your car. But instead of having a 12 volt car battery, we're using a power supply from an old PC tower to serve as the car battery. So yeah, I'll just give you a demo. I'm going to plug it into the wall. You'll see the charger come on and show you a proof of concept. Yeah, we got our charger. It's happy. It's getting its 12 volts in that it needs. I can, toggle it. Say I want to charge something, whatever. You're good to go, so to speak. Yeah, I'm just gonna show you how to test which circuits are doing what. So these often come with a label that decodes the wiring for you, but I'll just give a brief overview on this one here. Yellow is typically 12 volt out, black is typically ground, and if you take off the covering here, this obviously unplug it and stuff, and trace the wires back to the board, it'll be labeled on the board what each wire output is. But I'm just going to check it here with a voltmeter just to show you that yellow and then grounding to black is giving us our 12 volt DC out that we're using to charge batteries. And on these on this style, it doesn't have an external switch, so what you have to do is ground. Typically it's the green wire to ground, and that's what this little jumper is here. If I pull this out, it'll go off, put her back in, and it'll turn it back on. I don't have very big hands, but they're causing trouble. There we go. So it's back on. I'm just going to unplug it for this and talk about the label. So on here, the labels are usually pretty handy. It tells you what the power supply unit is capable of outputting. So it'll take an input, an AC input, and it's going to give you this kind of an output, these DC outputs. So it's got two 12 volt outputs here, a 14 and a 12 amp, and you can tie these two together to get you about 20 amps of output. And on this particular one, the yellow is one of the 12 volt outs, and brown is the other one. And you can trace that back to the board and read that off. So if I was to tie the brown and the yellow wires together, I could theoretically get 24 amps at 12 volts out of this power supply unit, which is pretty good. You could use a lot of chargers off of that. Okay, so I've hooked an older style of switching power supply unit. This one's a little bit different than the more modern one that I showed you. You have to pull a dummy load on the primary rail, which is it's the 5 volt rail. This is what would typically power the motherboard. It has a 20 amp output, so a motherboard's typically around a 4 amp draw. And what I've done is, for dumming load, I've taken a power resistor that's rated for about 1.5 ohms to simulate that motherboard load. You could use a tail light from a car or whatever. What's important is that you get about a 4 amp load on here, and I'm going to show you why. It needs a load on the primary so that the secondary rail, this is the 12 volts, it's gonna generate an actual true 12 volt output. If you don't have the dummy load, it's not going to generate the full 12, and it's not going to put the current out that you need. That's just how this technology works. It's a little bit older, but I wouldn't say run away from this style. You can do this, and you can still use this. You just have to be careful with these power resistors because they do generate heat, whereas like a light bulb's a little bit easier. I just put it across from, there's a fan on here that cools this assembly, so it's going to blow air over it and it'll keep it nice and cool. And obviously this is super janky looking, and it's just for visualization purposes. You could make a nice power supply unit box with proper banana connectors and things like that. But yeah, I'm just going to switch this on, and I'm going to show you what I mean about that dummy load. Okay, so I've got my meter here hooked up. It's on the yellow, which is the 12, and I'm grounding to the black. And on this one, it has a mechanical switch that activates the power supply unit. There, it's kicking on now. And you can see we're not pulling a true 12 volts on the secondary rail, and I don't have the dummy load hooked up just yet. Now I'm going to do that now, and what you'll see is this is going to jump up to 12 and a bit if I did my calculation correctly. Okay, so now we're pulling about a 4 amp load on the primary rail, and now we're getting about 12 volts out of it, which is what we want. And you can calculate what kind of resistance you need, kind of based on Ohm's law, V equals IR. We know we got 5 volts out. We know we want to draw a load of about 4.5 amps to simulate a motherboard, and then you can solve for R, and that's what that's representing. And just to prove that this would power this charger, I'm just going to take my probes here, and I'm going to hook them up to the charger, and I'll show that it would work as intended. Right? Way to the races. We could charge some batteries here. Yeah, I hope you found that useful. Again, if you get confused, the labels are very helpful. Removing the housing and looking at the board itself, it'll have what each one of these wires are, what they represent, what the outputs are, and I suggest tying together multiple yellows and black wires together for your application to reduce the resistance of the wires so you can charge batteries appropriately. And if you're really looking to do some heavy current battery cycling activities, these PC power supplies, they're okay. They'll do most, like receiver packs, this stuff, LiPos, like whatever, the basics. But if you're a racer and you want to cycle these things charge them as fast and draw them down as fast as you possibly can, like 40-50 amps, something like that, then a power supply unit from a server is much more appropriate and would provide the power you would need for that application. For my more modern one, this guy actually puts out about 24 amps on the 12 volt rail, which is pretty awesome because if you had multiple chargers, you could run multiple chargers and charge multiple batteries at the same time. This guy, it's only rated for 6 amps, so that's ample power. Hope you enjoyed that. Leave a comment. Happy to answer any questions. I hope you found this useful.